Hey Effendi, I'm going to make a screen recording here and just show some suggested improvements to your Epanet file because I think that'll be the best way to explain how I would do it. So the first thing will be treatment. So um, one thing we added to the PDT, the pump design tool, is the ability to accurately model the bypass line of the chlorinator. So when you have two chlorinators in parallel, you also have a bypass line. And most of the water flows through the bypass line, not the chlorinators. Um, and therefore the head loss is a lot less um, through the treatment. So I want to show that in Epanet. Let me move this box. So the way I model that in Epanet is I put a node here in front of the treatment. So I'm going to terminate this pipeline there at this node, junction 10. And then, oh, before I do that, I'm going to increase the node size to 4. It makes it easier to click on all the nodes. Okay, now the first, then I make a link going into the chlorinators. And this can represent the plumbing inside your treatment house. So that will be maybe 4 meters of pipe. It should be a diameter of 44, a 50 millimeter pipe based on the flow rate. And it may have a loss coefficient of around 6 for some elbows and other fittings. Um, that should be good enough. Maybe I'll increase the piping to 4 meters is probably good enough. 4, 5, 6 meters. I'll put 6. The next thing is I make this is just, I think it's the easiest way to keep it organized and neat. Make the chlorinators vertical. And then I include a bypass valve. And the horizontal valve is the bypass valve. The vertical valves are the actual chlorinators. And I set it to TCV. I put it at diameter about the same as the rest of the piping. I make sure all of this piping in between the chlorinators is the same as well as the rest of the piping, 44 millimeters, 1 meter. Then I'll move this pipe that goes to the tank. I'm going to move this down to after the bypass valve. And okay, so I made an error here. The bypass valve, no, this is correct. I just need to finish it. Okay, the last is this top line. There. Okay, so now when the water flows in and has two paths it could take. It could go straight through this bypass line and not be treated, or it can go through one of these chlorinators and then come down through this line. So the length of this pipe, this will be about 1.5 or 2 meters. Again, diameter of 44 millimeters. It's a 50 mm pipe. Roughness 135. That's good. Loss coefficient is going to be insignificant here. You can put, there will be an elbow, so you can put 2, or I guess 1. But the loss coefficients within here are going to be insignificant. That's why I just put a lump sum before. Then let's talk about the setting for the bypass valve. Use a TCV as your type. That means throttle control valve. So this valve is going to be throttled to control the flow between the bypass and the chlorinators. And the setting is how you control that in Epanet. Not loss coefficients, but the setting. So the higher number I put in the setting, the more closed, the more throttled that valve is, and the more water will go through the chlorinators. The lower value I put in the setting, the more water will go through the bypass, because the bypass will be more open. So 0 means fully open. I usually start with 100. These numbers are unitless, so it's just a scale that Epanet has. But I always start with 100. It's a good guess to start with. And then when I run the system, I can increase it or decrease it. So now I have everything set. I'm going to update elevations. So the elevation here is 63. Enter that in. 63. 63. So now this is how any system with multiple parallel chlorinators, this is how it should be modeled. It has a bypass line, and it has the chlorinators going vertical, and it has a throttle control valve to control that flow. And the target will be 50%. Half the flow going straight through the bypass, and half the flow coming through the chlorinators and going in this pipeline. And the PDT is modeling it the exact same way. If you put 50% in the bypass in the PDT, then you should have similarity between Epanet and the PDT, which is your goal. The last thing we need to account for is the water meter. So I don't know what pulse water meter you're going to use for this project. The 3/4 inch pulse water meter will be too small, so I hope you have some either 1 inch or 1.5 inch would be the ideal size. I will add another node here so I can model the water meter. So now this needs to terminate on 12. Valve for the water meter. And then let's see if a 1 inch will be good enough, have a low enough head. Add curves. Epanet, equipment head loss, SI units, pulse water meter, 1 inch. If I look here quickly, my flow rate is going to be 6 meters cubed per hour. 6. That's 100 liters per minute. At 100 liters per minute, this is right around 2 to 3 meters. So that's, honestly, that's more than I want. I would use the 1.5 inch. At 100 liters per minute, the 1.5 inch would be less than 1 meter of head loss. Again, I don't know what you have available, and you might be just procure one in country. If you can get pulse water meters in country, I recommend you do that and get a 1.5 inch. Copy, paste. Okay, now for the setting, I paste the same curve there. So now I have a water meter, and now this is modeled accurately. And I think that's all I need to do. You have a pipe coming out of the sump or spring box. You have, so let's run the system. And now we can see the flow is 113 liters per minute. And the head loss is 52 meters. If we compare that to the PDT, um, there we go. Compare that to the PDT, you have a lower flow and a higher head, and that's because we updated the head loss through the chlorinators and reduced it. So yeah, that's how you accurately model multiple chlorinators. There is one more update that I would like to make, one more improvement I would like to make to this model, and that is filtration. I think we might need filtration for this project because of the spring. And if we do, then I'll show you how to add filtration. The good thing is you have more flow and less head than you need right now. So I think we can add filtration and still produce enough water with the same pump, the same solar panels. So that's how I would improve your piping system to make it more accurate in Epanet.